Okay, so we're just reviewing some non-perfect squares. Remember to find non-perfect squares. You have to find what perfect is hiding out. What are two numbers that multiply to make 50?
25.
Yeah, that's the pair we want because 25 is perfect. And what is the root?
5 and 2.
So this is 5 square roots of 2. Over here for 175, what do you think of when you see the 75? What do you think?
5 and 7.
25 and 7. Good job. And we're going to take that 25 out by its root. So this is going to be 5 square roots of 7. Now, if there was ever like a teacher gotcha, it's going to be number 32. This is what I see all the time. Don't write this down. So when I grade some stuff, every once in a while I'll see work that looks like this. 4 is perfect. It was yanked out by its root, and then that's the answer that I've been given. And I can't give you credit on that because that's the square root of 8. Y'all, we just solved that. There's still perfects hiding out in here. So if you're trying to brainstorm and you're like, I cannot come up with any, just remember, if you have perfects in 2 of your factors, you can keep going. There's a larger perfect hiding out. There is a larger perfect than 4 that's hiding out. What else makes a 32 other than 8 times 4?
2 and 16.
2 and 16. 2 and 16. Good job. So let's write 2 times 16. We're going to yank out that 16 by its root. So this is 4 root 2. Now for the square root of 80, if you already know that, that's awesome. I'm going to pretend like I don't know it, and I'm going to show you how to figure it out. So for 80, I'm just going to say this is 8 times 10. Are either one of those perfect? No. So I'm going to keep going. So this is 4 times 2. And what's 10? 5 times 2. That is correct. So, guys, what is 2 times 2? What is this? That's a 4. So, 80 is really 4 from this times 4, which is that, times 5. And what's 4 times 4? 16 times 5 makes the 80. So, we're going to take 16 out by the root. So we're going to take 16 out by the root, and it's going to be 4 square roots of 5.
So why can't we do 4 and 20?
Well, because you have to do it again, because what makes up 20? 4 times 5, right? Another perfect square. So we're trying to find the biggest perfect square hiding out. Okay.
Okay, now hold it.
Okay. Okay. So, by the way, guys, you always need to show me exact form. If you put the square root of 8 in the calculator and get a decimal and hand it to me, I'm just going to have to give it back to you because So here we go with solving. Please write down x squared minus 100 equals y. And as you are writing this down, please visualize what this graph looks like in your head. By the way, I have seen some stuff on your sketch notes regarding this kind of problem. If you notice, the bx is missing. And if the bx is missing, what kind of form is it in? And standard. It is in both forms. So, what is the k value in this problem? Negative 100. What is the c value in this problem? Negative 100. The k and the c are the same exact thing when the bx is missing. We're going to solve this. So guys, on the next line of your work, drop that letter y and put 0. Y is always 0 when we solve for this. Oh, hey, before we go too far on this, Okay, where is the vertex in relation to the origin? Is it above or below? Where's the vertex?
Below.
It's below, way below. How many places
100
below?
Units.
100 places below. Does this graph open up or down? What's the A value? Positive. It opens up. So if the vertex is way down there and it opens up, will it cross the x-axis?
Yes.
Yes. How many times? That's a Module 3 question. Yes, it crosses twice. Module 4 is where does it cross? So now we're going to find the ordered pairs where they cross. So we're going to solve. So guys, push that negative 100 over to the other side. So we're going to have x squared equals 100. What do we do from here? Oh, we're square rooting. We're drawing that. What else are we drawing? Plus minus. Very good. So draw your square root symbol where it cancels out the little 2. We're going to square root the other side. Keep it balanced. X is going to equal a positive and a negative 10. Positive and negative 10. So where does this parabola cross the x-axis? Negative 10, 0, and where else? Positive 10, 0. Very good. Are you sure? Like, does the parabola really cross the x-axis? Yes, it really does. And I'm saying the word real on purpose because sometimes we're going to have to solve when it doesn't cross the x-axis. Please go to a next line of your paper and write this down. And this is the last on notebook paper, so maybe you'll have enough room. Let's solve this one. So as you write this down, remember the bx is missing. If the bx is missing, the k value is the same as what?
C.
Thank you. Very good. All right. So where is this vertex in relation to the origin?
100.
Way up, correct? And does this graph open up or down?
Up.
Is it going to cross the x-axis?
No.
Are you sure it really does not cross the x-axis?
Absolutely not.
We still have to solve it. So let's see what happens when we move here. Let me drop the letter y and put a 0. All right, we're going to move that 100 over. What happens to the sign? Negative. So when y'all were in Algebra 1, you got to stop here because you would write 3 words. No real solution. But now you're going to solve it using imaginary numbers. You got your ID?
Yeah.
Okay. You get to take roots of negative. Have y'all heard of imaginary numbers? Some of us have, some of them have. It's not a big deal. This is all it is. Wait for it. The square root of negative 1 is I. That's it. That's all an imaginary number is.
I don't like that.
So the square root of negative 100 is 10i. Kinda. We're about to draw a square root symbol, right? It's also a positive and a negative I. So x is going to equal positive and negative 10i. We had to solve it with imaginary numbers because it really does not cross the x-axis. If it really crossed the x-axis, we would have real numbers. It does not cross the x-axis, so we use imaginary numbers. I can't write that as or an ordered pair. You will next year. If you're taking pre-cal, you will. Not here, because the x and y axis only have real numbers. Okay.